derivative of a natural logarithm. It's usually pronounced ln here. So you have a function, g at x is equal to ln of some function, and it could be written like this. Ln x is like the most derivative version of it, the easiest version I should say. Blue. Then g prime x is equal to f prime x, so whatever that function is derived, divided by the original function. So if it's just ln x, that means it is then equal to, well, what is the derivative of x? We know it's 1, divided by the original function, x, right, which is kind of how they wrote those two. So that's all they're trying to say here, but what's the function within ln can be quite complex, so that's what we have here. So if you take a look, we have ln to the power of 3 of x over x squared plus 1. So ln to the power of 3 already is a little confusing. And I don't know if you remember or if you've done trig yet, but whenever we square like sine x, they'll be written this way because what they're trying to say there is that it's sine x squared. They don't want you to think that it's sine and then the x is squared. Okay, so that's why they write the squared. I shouldn't use disappearing ink here. My fault. Sine squared x is not equal to sine and then x squared. That's why they don't write the squared here. They don't want you to think that it's just squaring the x. What sine squared x is actually equal to is sine x squared. And that rule applies the same for ln. So if it's ln cubed, what they're actually saying is it is ln of this x divided by x squared plus 1, and all of that is cubed. Okay. So now if we're going to find y prime, we have a chain rule right off the bat. Because there's a function within this, we're going to derive the very first thing. So the very first thing, we bring the 3, so we get 3 over the original function here. 1 over x squared plus 1 to the power of 2. And then we're going to need to multiply it by the inside here. Am I correct? Yeah. So we got to multiply the inside here. So the inside here, we have, we can use our ln rule, and we're going to have to find the derivative of this. Here we're going to probably use a quotient function. So if, we'll use kind of an if statement on the side, if we have f over g, the is equal to y, let's say, then y prime is f prime times g minus g prime times f over g squared. Okay, so that's where we're going to relate this. Our value on top is our f, okay, and our value on the bottom is g. So we will then derive this in the second part here. So the very first, the top part of this is quotient identity. So the whole thing we have to derive. So we're going to derive the whole thing first, and then we're going to divide by the original. So actually what I'm going to do is I'm going to write the original underneath here. The original is our x over x squared plus 1. Okay. That's the original function here for the ln, because remember we need f at x on the bottom. So that's the original function. We haven't actually addressed the quotient. The quotient identity will be everything on top here. So I'll kind of highlight it in blue. This is where we're going to write our quotient identity. I just wrote the original ln on the bottom because we keep the original function now. And I know that was kind of confusing when I read the quotient. Does that make sense now? Yeah. Okay. So let's actually go through this. F prime is our x, so that's 1, times g prime. Well, we have x squared plus 1, so that's going to become 2. Oh, no, not g prime. Yep, just original g. As soon as I start writing that in, it's correct. There you go. Times x squared plus 1. Okay, that's good. That's our f prime times g, so we'll kind of cross that out that we've done that part. Subtract, we'll put it in brackets. Next set of brackets. G prime, well, g prime is 2x. There's that. So we're going to have our 2x here times the original f, which is x. So 2x times x. And all of that is divided by g squared. Well, g squared is our x squared plus 1 and then that squared. So we got a whole lot of fractions working out here. I'm going to leave this original part here right now, and we're going to focus on what we have here on the simplification of this, because we've now derived everything, but the simplification is going to be a little difficult. So let's kind of bring this down here and focus on, I'm just focusing on the part in the red brackets. 1 times that, x squared plus 1 is just going to be x squared plus 1. 2x times x will be 2x squared, and we'll be subtracting it, so minus 2x squared. And that will be divided by. So I'm going to consider this part here as like my first fraction, and this part here as my second fraction. And I'll, instead of putting them over each other, I'm going to write a division sign here instead. Okay, so think of this as the blue part that I talked about above. And on the bottom, I could use distributive property and distribute this, but I'm just going to leave it right now at x squared plus 1 squared. On the bottom here, we still have our, I'll write in green, x over x squared plus 1. Okay. Yeah. So now we're going to invert and multiply across. I could actually simplify this part here. I'm going to simplify this in this one step. This is actually just going to become negative x. Negative 2x squared plus x squared will be just negative x squared. There you go. Just negative x squared. Can I move that? Ooh, not bad. That worked out good. So 1 plus or minus x squared. Which I could turn into... Okay, we'll leave it as right now. We're going to still working on those red brackets. This one's complex, those red brackets. We're going to multiply our fractions. So we're going to invert and multiply. So this thing is going to flip. So we have x squared plus 1 over x. And on this side, I'll write this in blue now. Negative x squared plus 1 over 2x plus 1 squared. Okay. When we multiply, they're just, think of it just like we're extending this line, right? And these are now multiplied by each other. Get rid of that x there.
Can't you cross?
Yes. So because this is squared and this is just to the power of 1, though the bases are the same, this one will disappear. This one will actually just drop to the power of 1. And then we're left with still just that red part. Remember, I still haven't even dealt with that left side. We have negative x squared plus 1 on top, divided by x squared plus 1 times x. We could distribute the x. Will that be helpful? This is technically a difference of squares. I could break that open too. I don't know if it's going to be helpful. So what I'm going to do from this step is I'm just going to start moving everything back to its place and see if it will become helpful with the rest of the equation. So now I'm going to kind of pull what we had before. 3 ln x squared. So our y prime, so I'm kind of re-bringing back everything down. 3 to the power base ln x over x plus x squared plus 1 squared. And these things are multiplied by each other. So let's take a look at that. And this is essentially it. It looks like in your book, I guess we'll refer to how the book's answer was to show how we have the same thing. Let's say the book was in blue here. They'd written y prime is equal to 3, 1 minus x squared, x times x squared plus 1, multiplied by ln 2 to the x over x squared plus 1. At first glance, these don't quite look the same, but let's focus on how they've written these things. First of all, think of this as this part here is this. They've just used that rule we talked about where you can take the power and just apply it to the ln and put this in brackets. That's exactly what it is, ln 2, x and over x squared plus 1. Check, we got that part. They actually took the 3, and because of the rule of multiplication, it's called associative property. You can multiply in any order. They decided to multiply the 3 here. That set of brackets, these two terms are just switched places. So there's a 3, and they put the 1 first and then negative x squared after. Remember I said this is a difference of squares. This one's easier to see. You could have broken this into 1 plus x, 1 minus x. Is it helpful? I mean, maybe, depending what we're doing with the equation. This is fine within itself. And then on the bottom, again, they've just reversed the order. They've put the x in front and have x squared plus 1, which is exactly this. So the exact same thing, but visually quite different what they got to, or what our answer and theirs was there.